Math 113, Lesson 7-1, the law of sines. Now, up to this point, we have been using trigonometry, which deals with all right triangles, because in our right triangles, we have a right angle. Well, we need the law of sines because sometimes we have triangles that are not right triangles. So, we are going to use law of sines when the triangle is not a right triangle. Okay, when it is not a right triangle, which means we would have 3 acute angles, or we might have 1 obtuse and 2 acute angles. All right, so here's what the law of sines says. It is a proportion and so when you look at A, B, and C, big A, big B, and big C all represent angles. Little a, little b, and little c represents the sides that are across from that particular angle. So notice that little a is across from angle A. And you could say the same for little b is across from angle B, and little c is across from angle C. Now, sometimes law of sines, you may see it in my math lab occasionally, and they write it upside down. Well, that doesn't change anything as long as all of them are flipped over. So either one of these is appropriate. It does matter that you have capital A, B, and C, and little a, B, and C in the same spots. Excuse me. Okay, so let's start with a triangle where we have one side and 2 angles known. Let's start there, because this case is actually the easier case if we are given one side and 2 angles. All right, so we are asked to solve the triangle, which means find all the sides and measures that you don't already know. And I'm going to give you that A is 64 degrees. Okay, capital A is an angle. Capital C is 82 degrees. Again, that is an angle. And little c is 14 centimeters. So that would be a side opposite angle C. And we're going to round our final answers to the nearest tenth. Remember, I said your final answer. Okay, so the first thing that I want to find is angle B, because that's an easy one. We know that the angles of a triangle add up to be 180. So angle B, I can just take 180 because I know that's how much all the angles add up to be. Subtract from that the sum of the 2 angles I do know. So add up the 2 you do know and subtract from 180. And so I would get 180 minus 146. And so angle B is 34 degrees. All right, so we've done one small little thing. Now we also need to find little a and little b. Okay, we found big B. We need to find little a and little b. So those represent sides. All right. So now I'm going to go to the law of sines. Now, when you start using law of sines, use known information first. Okay, so here's what I mean by that. We use the known information first. This information was known. It was given to us. So let's use that. Okay, so our side is 14 over the sine of the angle opposite it would be 82 is equal to, now if I'm looking for little a, I have to put it over the sine of a. Now, I'm not going to put the other fraction. I'm just going to work with this and solve this proportion. All right, solve this proportion. Now, here's what I mean. We're not going to do any rounding until the very end. So I'm going to show you all my little steps here, just so I can show you what I mean. We are not touching our calculator right now. Just doing the algebra. Cross multiply. To get a alone, I divide both sides by the sine of 82. All right, so before I touch my calculator, there's one thing I need to make sure of. I need to make sure my calculator is in degree mode, because you just always need to check. Sometimes calculators, their default is radian. So first check, make sure your calculator is in degree mode. Then you can type this in your calculator. Okay, so I'd like for you to actually type it in and see if you get the same answer that I get. Okay, when you type that all in and then you round at the very end, we should all get exactly 12.7 centimeters. We all round exactly the same. So here's what I don't want you to do. I don't want you to do sine of 64 and write something down. I don't want you to do sine of 82 and write something down. Okay, because then those are two rounded answers. Don't round until the very end. All right, so we found little a, we found big B, now we need to find little b. So I'm going to go back to my known information, which was the 14 over sine of 82. Those two were given to me. Now to find little b, I'm going to use the sine of 34. We found 34. Okay, again, I'm going to do my algebra. Not touching my calculator just yet. Divide both sides by the sine of 82. All right. So you type that in your calculator, see what you get. Again, making sure that your calculator is in degree mode, because that matters a whole lot. Okay, and so hopefully you've gotten an answer. I was just trying to give you a chance to type it in your calculator yourself. I want to make sure that you get the same answer that I get. And we should all get 7.9. We round to the nearest tenth. 7.9, and these are centimeters. It was the length of a side. So we found the missing angle that we didn't know, and we found the two missing sides that we did not know. So I would say that that's one of the easiest cases that we can have when we are given two angles and a side. Okay? All right, there is a thing called an ambiguous case. Now this one is a little bit more difficult, not a whole lot more. The ambiguous case is when you are given one angle and two sides. Okay, because there's more than one triangle that you could get for an answer, or possibly you could get none. So let's go over what our ambiguous case would be. Since these are not right triangles, then we don't have a right angle, right? So the height of our triangle, for the moment, I'm going to label as h, okay? For the sake of what we are doing here, I'm going to label that h, all right? And I'm going to put A here, B, and C. So this would be little a, this would be little b, and this would be little c. Okay, so my ambiguous case, the first thing you need to check for is the value of the height. All right, because it matters. Okay, so we need to check the value of the height. Now you won't always see the triangle drawn. So here's our formula. To find the height, we're going to multiply b times the sine of a. All right, we're going to multiply b times the sine of a. And then we are going to look for a few things. The value of a if it is bigger than h, and the value of a if it is bigger than b. If these two things are true, then we're going to have one triangle answer, and that's the easy case. All right, that's the easy case. If we have, again, we check for that height again. If I get that a is equal to h, then this is a right triangle, and so we're not going to need law of sines at all. If I get a is less than h, then guess what? There's no triangle at all. Okay, if a is less than h, if the length of a is less than h, then this is not even possible. If you look at that diagram that I have drawn for you there, in that diagram, if I pay attention to this triangle, a would be the hypotenuse of that particular triangle, since there is a right angle there, and the hypotenuse should be longer. Okay, so if a is shorter than the height, then this is not a triangle at all anyway. Okay, and then the last case would be if a is greater than h, but a is less than b. Okay, if that is the case, there would be two triangles, which means we got more than one option for answers. This is an A. Okay, if A is less than B. All right, so there are our cases. So we're going to you need to jot this down, okay, this information, so that you can have it beside us as we work the next problem. I'm going to do one that is an ambiguous case. Okay, so make sure you have this written down because we're going to need to refer back to it. Okay. So example number 2, we are going to solve triangle ABC. I'm going to give you that A is 57 degrees, so there's the angle that we know. Little a is 33, and little b is 26. Okay. Let's round all of these to the nearest whole number. Okay, so pay attention to in my math lab what they ask you to round to. All right, so we're going to round this one to the nearest whole number. All right. So I'm given one angle and two sides. So when I know for sure that I'm given one angle and two sides, the first thing I need to find is h. All right, and then compare the value of a to h and a to b. All right, so let's find our h value. Okay, h is, we take the b value, which is 26, and we multiply it by the sine of angle A, in this case is 57. All right, so let's get a value there. So in our calculator, we actually do that. We get 21.8 for the height. Now, I need to, what do I know about the value of A? Well, A is greater than H, okay, because A is 33. All right, now let's look at A and B. A is also greater than B. So if we use that information I just gave you, that means we're going to get one triangle. Okay, that means, wow, this problem is so much easier. There's nothing extra I'm going to have to do. Okay, so we're going to just start working this problem because there's only one option for an answer. Okay, so we'll start working. Again, we'll start with our known information. So 33 divided by the sine of 57 is equal to, we know little b, so let's find the sine of angle B. All right, so let's do all the algebra first. Okay, now I want to divide both sides by this 33. Okay, now We're going to see how much you remember about before. How do I get b alone? You don't divide by sign. Okay, so we're looking for some angle whose value of sine is that, whatever that decimal is over there. So a couple ways I can do this. I could actually get a decimal for that side on the right. So do 26 sine of 57 degrees and then divide by 33. All right. Now I'm going to go several decimal places. All right, just to make sure that I'm good. Now that's not my answer. I need to know what b is. So b, in order to find that, we do the inverse sine of that decimal to find out what angle b is. And then we're going to round it to the nearest whole number. And you should get 41 degrees. So actually type that in your calculator. I'm going to give you a second. Make sure you actually got those numbers. All right, so we've got angle B. Now we were already given angle A, right? So I can go ahead and find angle C by saying 180 minus, add up the two angles that I've got. I just found 41, they gave me A was 57. So when I do this, I will know what angle C is. So C is 82 degrees. So I found two of my answers. B is 41 degrees about, and C would be about 82 degrees. All right, and now I have to find little c. Okay. So little c, I'm going to go back to the information that I was given. Little a over the sine of A is equal to little c over the sine of, we just found C was 82 degrees. Okay, now cross multiply. All my algebra first. Okay, now to get C alone, I divide both sides by the sine of 57. Okay, so now you can type that in your calculator to get little c. And now we're rounding to the nearest whole number, so we should end up with 39 centimeters. So little c is 39 centimeters, big C is 82 degrees, and big B is 41 degrees. So that one was actually a really good case because it was only a one triangle option. I am going to do an example of the others so that you can see what that even looks like. Okay, so again, I'm given one angle and two sides. When you are given one angle and two sides, the first thing you need to find is h. So let's start with h. So we take our b value and multiply it by the sine of angle A. So type that in our calculator, and we get that h is about 15.3. Now, we compare that to A. Well, A is less than h. And so if you look at that information that I gave you earlier, when A is less than h, there's no triangle that's going to work. So this problem, there is no solution. And we can stop right there. Now, my math lab might go through the trouble of setting up a sign, but I'm telling you, the first thing you need to do when you're given one angle and two sides, go ahead and find h and use that information, because no triangle works out so that A is less than h. It's not possible. So we're done. All right, again, we're going to solve triangle ABC. A is 35 degrees. Little a is 12. And little b is 16. Again, we are given one angle and two sides. So the first thing we need to find is HB times the sine of angle A. Okay, so do that in your calculator, and we get 9.18. Okay, now we compare that to A. So A is greater than H. That's good news. Okay, so it's definitely a triangle. And now we compare A and B. A is less than B. Okay, so when I get that combination, then I'm going to have two triangles. Uh-oh. That means the remaining information, okay, that means we are going to find angle B and little c, okay, to go with the information that's already here, okay? And then on the other triangle, oops, our other triangle, we would have angle B and little side C. Okay, so we get two different sets of answers. All right, so this is the one that is a little bit more complicated. It's just a little extra step of work. It's not hard work. Didn't even know that was a thing. Didn't know I could do that. Okay. So let's get to work. All right, so we know we're going to have two answers. Let's go ahead and find one. Let's start with the information that's given. We know little a is 12, the sine of A. I know that B is 16, and I'm going to find my first big B. So I'm going to name it B1. Okay, B sub 1. Because I'm going to get two different B answers, so I'm just getting one B answer for right now. Okay, do my algebra. Divide both sides by 12. Okay, so you can get a decimal in your calculator for that right-hand side. And you get 0.7647669. I just like to carry it out several places. Now to find angle B, I am going to do the inverse sign of that decimal. So my first angle B, and my round to the nearest whole number again, is 50 degrees. Awesome. Okay, so I'm gonna go back and write down what I know. They gave me angle A was 35. They gave me little a is 12. Gave me little b is 16. I just found B1 was 50. Okay, and there's going to be a C1 that goes with that. Now, there is also a different big B and a different big C. We are going to have a little c. I should have written these a little differently. Let me move it over. All right, so that was all the given information. All right, so when I find B2, I'm going to have an A value, a B value, a C value, and then I'm going to find a little c value that goes with these. And then I'm going to find a little c value that goes with these. Okay, because this given information up here stays the same every time. All right? Okay. All right, so if I know that A is 35 and B is 50, I can find this other C1. Okay, C1 will be 180 minus, go ahead and add the 50 and 35. So C1 is going to be equal to 95 degrees. Okay, because 180 minus 85. Okay, So 95 goes right here. Okay, because these three angles have to add up to be 180. All right. I don't know the other big B or big C just yet. Okay. Now here's what I do know though. Okay. I found that B was 50 degrees. Now let's think about that. That is in the first quadrant, right? 50 degrees be about right here. So let's think about what we know about angles. 50 degrees. Now we know that sine repeats itself, right? Smart, trig, class. The value of sine here, remember sine is our y value. The value of sine here is the same as the value of sine in quadrant, not that quadrant. Okay, in quadrant 2. This y value is the same as that y value. Okay, so if I use a reference angle of 50, then that whole angle right there in the second quadrant would be 130. So a 130 degree angle is the other option for my angle. 130 degrees is my other option for angle B. Okay, so if I go back to A is 35 and B is 130, then C, this should be a 2, sorry. C2, I take 180 and subtract, I add 35 and 130. So C2, not sure what happened there, would be 180 minus 165. That gives us 15 degrees. All right, so I found B1 and B2, C1 and C2. Now I need to find the sides C1 and C2. All right, so let's keep going. Okay, so let's find little c1. That means we have to use angle c1. Okay, remember angle c1 we said was 95, so 95 degrees. And then use the known information, 12 over the sine of angle A. All right, so we'll solve this. Use my algebra first. Divide both sides by the sine of 35. And I get little c1 is about 20.8. Little c1 is about 20.8. I think I told you whole numbers, so 21. All right. Little c2, we have to put that over the sine of angle c2, which was 15 degrees. And again, we'll go back to the information that was given for the rest of the proportion. So use our algebra. Okay, divide both sides by the sine of 35. Type that in your calculator and you should get 5.4. I did say whole number, so C2 is 5. Okay, so we found all of this information. Okay, they gave me one angle A, little side A and little side B. I found out that there were going to be two triangle options. Okay, so triangle A1, B1, C1, I found everything that goes with that. And then triangle A, B2, C2, C2, I found everything that goes with that. All right, so that's why this one was a little bit harder case. It's just a little bit more work. Okay. So those are our two cases for using the law of sines. And the area of just a regular old triangle, we just say 1/2 base times height. But what if it's the area of an oblique triangle, which just means that it's not right? Okay, that just means that it is not a right triangle. Right, so it could be acute or it could have an obtuse angle, it doesn't matter. Okay, so I'll draw one that appears to be acute. Okay, so to find the area of this triangle, usually we know the height because we have a right angle. Well, we don't have the height this time. So the formula for finding the area of an oblique triangle is we say 1/2 BC times the sine of angle A. Or, let's say it was given different information. Okay, that's a little confusing to see those two A's. Area. So 1/2 A times B times the sine of C. Okay, it depends on what information you're given, which formula you choose to use. Okay, notice if I have angle A, little side B, and little side C, I use the first formula. Okay, so you could use any of these. So these are or. Okay, you could use any of these to find the area of a triangle. Now here's what I do want you to understand. Notice that if I know B and C, okay, angle B, I'm sorry, side B and side C, then I use angle A. Well, notice that that angle is the angle that is between side B and side C. So we call that the included angle. Okay, that's just the angle that is between the two sides B and C. So if we look at the second equation, I'll do that one in this color. So if I have A and B, okay, A and B. Well, notice that angle C is the angle between A and B. So C would be the included angle in that one. So it is important to know that that angle is the included angle. In my math lab, will likely use that vocabulary. So if I said, find the area of a triangle having two sides of lengths 8 meters and 12 meters, and an included, that's that word I just used, an included angle of 135 degrees. Okay, so our little formula says, all right, to find the area, I say 1/2 times the two sides that I know, times the sine of that included angle. It is important that they told us that was the included angle. Now, I am not looking for a calculator answer here, okay? We can do the sine of 135. So, 1/2, 8 times 12. Let's do the sine of 135. The sine of 135 is in quadrant 2. Its reference angle is 45. So I know the sine of 45 degrees is the square root of 2 over 2. 135 is in quadrant 2, so it is also square root of 2 over 2. Awesome. All right, so now I'm ready to multiply. So that gives me 4 times 12 times square root of 2 over 2. 48 times square root of 2 over 2. So that gives me 24 on the square root of 2. And these would be meters squared. Now, if it asked you for an exact answer, this is what we give. 24 on the square root of 2 meters squared. Now, if it asked me for a decimal, I could actually do the decimal. And if I do the decimal and then round to the nearest whole meter, it would be 34 meters squared. So again, paying attention to the directions, if it asks you for an exact value or it says you can give a decimal answer. And that is all for section 1, Law of Signs.